Let's talk about a voltage buffer, or voltage follower, or unity gain op amp, operational amplifier. Now, where would you use one of these? Say you have a this voltage divider here. These happen to be both 10 k ohm resistors, and we're putting 10 volts in. And to find your voltage out, you just take the V in times R2 divided by R1 plus R2. In this case, we have 10,000 ohms up top and 20,000 down below. We can get rid of the zeros. It's going to be 1/2 or 0.5 times our 10 volts. We're going to get 5 volts out of this unit here. Now, if we put a load on there, say a 2K load, then these two resistors are in parallel, and that's going to change the resistance here. And we can use this formula here. This R total is equal to R1 times R2 divided by R1 plus R2 to find this resistance here. And if we do that, take our 10K times 2K divided by 10K plus 2K, when we divide that out, it comes to 1,667 ohms. It's always going to be less than the smallest resistor you have in here. Now, if we take this number and we plug it back up into this formula here, it turns out to be about 1.4 volts across here on the output. So we want 5 volts, but we're only getting 1.4 volts out. Now, if you know the load and it doesn't change, you can adjust the resistors to get your 5 volts out here, and that's fine. But you can use an op amp in unity gain, and there's two rules on an op amp. Now, the first one is no current flows into the input. This is your non-inverting input, and a perfect unit, nothing will flow in here. And whatever voltage you have on here, say we have 5 volts here, it tries to put 5 volts up on this inverting input up here. And it'll do that through the output. We have a negative feedback here, so we have the output tied to pin 2 over here. So if we put 5 volts on here, it's going to do whatever it can to get 5 volts up here. Now, I'm using an LM741. They're older units. They're not the best. You could probably get a better unit, but they have a null offset, 2 of them. It's pins 1 and 5. Now, with those 2 pins, you can adjust the voltage on here. When I first set it up, when I put 5 volts on here, I was getting like 6 volts out of here or something. But if you take let's say 10K pot and put it between pins 1 and 5, and then tie the center to the negative here, the negative supply. This happens to be, for me, it's 13.8 volts right now. I'm putting in here. Different than this supply over here. And if you do that, you can adjust this pot to equal out these voltages here for you. Compensates for anything that's not quite right with the op amp. Now, these op amps are only good for, say, maybe 5 milliamps, 10 milliamps. They make higher power ones, but for the most part, they don't put out much current. So you can add a resistor or a transistor to it, and I took the base of this transistor. I think this one's a 2N222, just a jelly bean transistor. Took the base of it, tied it to the output, and then the negative feedback comes back here off the emitter here and goes to 2. So if we put 5 volts in here, it's going to do whatever it can to make sure we got 5 volts over here on this point here coming out here. And I'm going to ground. I'm going through a 47 k ohm resistor to give us some load for this thing. And then your output's over here. You get your 5 volts off of here. And with this unit, I can maybe I don't know, they're 100, 200 milliamps. You can always add another transistor in a kind of a Darlington arrangement on here to get your current up higher. But we'll take a look at the breadboard here. Well, it's a little sloppy there, but here's the I knocked this off. Get our voltage back on there. All right, can you see that? I'll tilt it up. Get the wires out of the way. We've got 5.2 2 volts coming in and 5.2 volts coming out, and it doesn't matter what load we have on there, we're always going to get our 5 volts out of there. But that's a voltage buffer with a operational amplifier. Thank you.